Today we're going to be talking about how the atmosphere is heated. Now that you know the structure of the atmosphere, how temperature varies in the different layers of the atmosphere, we're going to talk about how heat actually moves through the atmosphere, how it reaches the surface of the planet, and why that's so important. So energy transfer as heat. First question for you. What is heat? What is temperature? What's the difference? Well, heat is the transference of energy from one object to another due to a difference in temperature. So think about heat as coming out of your heat vent at home. The room is cold. This warm air is blown into the room. So there's a transference of energy from the warm air to the cold air, and that heats up the room. And when I say transference of energy, what I'm actually talking about is the air molecules bouncing off of each other and creating that kinetic energy. The energy, what kinetic energy creates that we feel is heat, and kinetic energy is just simply molecules bouncing off of each other, and the faster they move, the more the heat. So energy always moves from a warmer object to a cooler object. That's one of the laws of thermodynamics. I believe it's the second law of thermodynamics. So always moves from warmer to cooler. Temperature is a measure of average kinetic energy of atoms. So heat is these atoms transferring energy from one another, and temperature is actually measuring that kinetic energy. So the faster the atoms move, the higher the temperature. The slower the atoms move, the lower the temperature. So the next time you ask, what's the temperature outside? What you're actually asking is, how fast are those atoms moving outside? How do you think energy is transferred in the atmosphere? Because it has to be. How else would the heat from the sun reach our planet? How do you think? Well, there are actually three ways. First we're going to talk about is conduction. It is the transfer of heat through matter by molecular activity. So it is molecules bouncing off of each other as you see in this image. And the faster they move, the higher the temperature. The slower they move, the lower the temperature. So heat moves through an object as the molecules are colliding, as the atoms are bouncing off of each other. There are some good conductors of heat, like metal, which is why we make cooking pots and pans out of metal, because it's able to transfer the heat from the heat source to the food. And then there are poor conductors of heat, like air. Why conduction is important only between the Earth's surface and the air directly in contact with the surface. So the transfer of heat via conduction only happens between the surface of the Earth and the air that lays right on top of it. And then this would be an example of conduction, is if you have, if this were a metal bar and you placed a heat source at the end, that heat would slowly start to move down the metal bar via conduction, because it's heating up the molecules here. It's causing them to move faster and faster, and as these molecules move faster, they start bouncing off of their neighbors, and those neighbors start bouncing off of their neighbors, and pretty soon, via conduction, the energy that is creating heat, kinetic energy, is moving down the bar. And then we have convection, second type of heat transference. It is the transfer of heat through matter by circulation of substances. Let me explain what that means. It occurs in liquids and gases, and it's common in Earth's oceans and atmosphere. So essentially what is happening is the atoms are free to circulate through the ocean or the atmosphere or the liquid or the gas, and warm water or warm air is less dense, it weighs less, and so it rises higher. Cooler air is more dense and heavier, so it sinks. So it creates this convection current that goes around in a circle. Hot air rises. As it rises, it begins to cool. As it cools, it becomes heavier, so it sinks down again. As it sinks, it begins to be heated, and as it becomes heated, it becomes lighter and lighter and begins to rise again. So most of the heat in the troposphere is transferred by convection flow, which we see here. So we have conduction, which is heating the layer of air that is right next to the surface of the Earth. And as that heat rises up from the surface, it is heating the air that is just above it, and as it heats it, that air becomes lighter, so it rises in the atmosphere. As it rises higher, it begins to cool. As it cools, it becomes dense, and so it sinks back down, and the whole cycle begins again. Solar radiation is the transfer of heat through electromagnetic waves. It doesn't need a substance. It can actually travel through a vacuum, which is why the sun's rays are able to reach Earth. Space is a vacuum, but yet solar radiation can travel through it via a wave. So 3 different results occur when radiation strikes an object. Some of the energy is absorbed. Some of it is transmitted by water and air because they are transparent, so the waves can move through it. And some bounce off of objects without absorption or transmission, so they are reflected back. Some incoming solar radiation is used for photosynthesis. So some of the incoming solar radiation from the sun is absorbed by plants, and those plants use the solar radiation in order to create food because they are autotrophs. So this is an image of solar radiation, and this image should look familiar because we saw something similar in the Introduction to Climate lecture. So we have 100% of solar radiation coming from the sun, 50% of it is absorbed by the surface of the Earth. 5 of it is reflected back, scattered back out to space. 20% is reflected by clouds. So there's a lot of different paths for solar radiation, a lot of different ways that it is absorbed and reflected back into space. Alright, let's talk about electromagnetic waves, because we can't talk about solar radiation without talking about electromagnetic waves. What an electromagnetic wave is the entire range of wavelengths or frequencies of an electromagnetic radiation from gamma rays to the longest radio waves, and this includes visible light. And electromagnetic waves, they're like ripples in a pond. The electromagnetic waves move out from the source in various sizes depending on the type of wave that it is. And this is how radiation travels. So this is known as the electromagnetic spectrum, and what this is measuring all the different lengths of types of waves, and you can see that radio waves are the longest, gamma rays are the shortest, and right in the middle we have visible light, which is what we can actually see. So these are measuring in frequency the different lengths of the different types of waves. And this is how radiation is able to travel from the sun through the vacuum of space, through our atmosphere, and finally be absorbed by our planet. Alright, so I want you to compare conduction, convection, and radiation. How do they move? Where do they come from? What are their sources? So they move energy from place to place. Radiation, this is radiation, which is the sunlight warming the ground, coming in via waves. Conduction, the warm ground heats the air, so the radiation from the sun is absorbed by the ground. It is then via conduction, it heats the layer of air that is directly above the surface of the ground, and as it's doing that, what conduction does is it heats this bottom layer, and then that heat actually heats the layer above it, and it creates this convection cycle that we talked about earlier. So what effect do you think heat transference has for the planet? It has a lot of effects, so let's talk about them. It affects ocean currents. It affects atmosphere. It affects wind in the atmosphere. And it also affects nutrient cycles like the water cycle, which we will talk about soon. Let's talk about ocean currents and winds, though. So remember this key idea from our Intro to Climate lecture? Ocean currents are caused by winds. Winds are caused by the uneven heating of Earth's surface. So we have this solar radiation that's coming in from space via electromagnetic waves, and that solar radiation is heating the surface of our planet. That heat is then radiated back up into the atmosphere, first via conduction, because conduction is heating the bottommost layer of our atmosphere. When that bottommost layer becomes heated, it begins to heat the layers above it via convection. It creates these convection cycles where as the air is warmed, it becomes less dense, so it rises. As it rises higher into the atmosphere, higher into the troposphere, it cools, because the higher the elevation in the troposphere, the lower the temperature. As it cools, it becomes heavier and it sinks again, and it creates this convection cycle. And that convection cycle is what we feel as wind, and that wind blows over the surface of the oceans. And as it's blowing over the surface of the oceans, it's actually creating convection cycles within the oceans themselves, and those convection cycles are what create ocean currents. And ocean currents and winds are part of what create climate in our planet. So it's all interconnected in a really beautiful way.